Hello, and welcome to the training module, NETCONF and YANG Concepts. This module provides a basic introduction and orientation to the concepts of the NETCONF protocol and the YANG data modeling language. Subsequent modules will provide detailed technical tutorials on each of these subjects. This module provides the initial introduction. So, at a high level, what is NETCONF? What is YANG? So NETCONF is a modern network management protocol. It's specifically designed to support service activation and provisioning, meaning it has features that are useful not just for configuration management of individual network devices, but has certain features that can be leveraged across multiple network devices for service activation and provisioning. It provides and is designed from the ground up for encrypted efficient transport. It is transported over SSH and TCP protocols to provide security and reliability. It is an XML framed protocol. In fact, for those of you familiar with it, it is an XML RPC style protocol. If you're not familiar with that, we'll understand that a little bit more later in this series. NETCONF is an extensible protocol. You can actually add new operations to the protocol. It is a transactional protocol. It is designed from the ground up to provide support for transactional configuration changes in network devices. Your changes all succeed or they all fail. Transactions are important to avoid unknown, inconsistent, indeterminate configuration states in our devices. Transactional support avoids that. It also provides certain features that we'll see that make it easy to do network-wide configuration changes to easily activate services in our network. Where NETCONF is the protocol, YANG is the data modeling language that describes the management capabilities of our network devices. It's very operator friendly. It's very easy to read a YANG data model and understand what's there, how the data is organized, and how the device works. It's very precise. You can very accurately describe the data that you're managing in your system with no real, unusual things of, oh, this is an integer. It can take on any of 64,000 values. You can, with YANG, say if there's only a certain set of valid values, those can be specified precisely in YANG. Again, just like NETCONF was designed to be extensible, not to lock people in if something is useful in the future to extend, YANG is designed to also be an extensible data modeling language. It is also a very readable language. When YANG was first being designed, a simple observation was made that the number of readers of a YANG data model is much, much greater than the number of writers of the YANG data model, which is much, much greater than the number of people who write YANG data model parsers. So being a human readable language is an important property of YANG and ease of readability. So what makes NETCONF and YANG different? Well, every few years you've heard about some new emerging network management standard. There's the hype, there's the promise, there's the hope that everything will be great. But, in the end, we just added maybe one more management interface into a network device that ended up just simply increasing the complexity and difficulty of managing an overall network. There's many of them you see, listed here on this slide. But, when I'm saying that NETCONF and YANG are good ideas or a good way of managing a network, why should you believe it just because someone's saying it? Well, that's what we want to talk about through here. So Let's just take a look at, comparing NETCONF to a couple of alternatives, SNMP and SOAP. How are they transported? Well, SNMP, when it was first designed, was simply designed to run over UDP with no sort of security. Back then, our networks were simple, easy. You didn't need to worry about security. Later on in SNMP, we bolted it on, we added it. In the NETCONF world, we simply leverage TCP, which gives us reliable connection, whereas UDP's datagram unreliable. You don't know if the packets get there. Did the device get it? Didn't it? I don't know. I got to read something back. Did it take hold? With NETCONF, since we're over TCP, we know it got there because we're on a reliable protocol. SSH is a well-known industry standard security protocol. NETCONF has carried over that standard. SOAP, well, we do have TCP. On top of that, we run HTTP and SSL. So we have some reliability, we have some security there. How do we express the protocol itself? For sending RPCs to the device to execute. Well, SNMP, we had BER encoding, which, very difficult for human to just take a dump of that protocol and read it. Whereas NETCONF, SOAP, we do have XML. But then when we get to management operations, we've got our protocol, but what sort of operations can we use in managing our network? Well, in SNMP, it's simple network management protocol. There are management operations that were designed as part of the protocol. Similarly for NETCONF, it's a network management protocol, so those management operations were designed in. However, SOAP was more of just a transport linkage. It wasn't designed for network management specifically. It was more general purpose. So, here we get to a big difference of SOAP not having management operations designed in. If we keep going up, though, past those management operations, so we can do management operations. What are we managing? What is the data that's there in the device that we're going for? So that's where the modeling language comes in. What language do we use to describe our data? Then what sort of models do we have? So in the SNMP world, the language is SMI. That language is used to write the data models, and then in a MIB, you use SMI to describe the management information for SNMP. In the NETCONF world, we use the YANG language to write a YANG data model that is then used. Now, we've seen how SNMP and NETCONF, they're management protocols. They have a modeling language. They have models. Doesn't that mean they're all the same? No, absolutely not. If we look into those differences, SNMP, okay, yeah, we can get information, we can set information, we can get notifications. With a NETCONF, we can get configuration, edit configuration, delete it, get, log. So, so what? Are these just really the same? No, not really. The difference here is the supported use cases. For example, when you want to fetch monitoring information from a device with SNMP, since it's carried over UDP, you're limited to either writing config data or fetching config data for what fits into that 64 kilobit limit on the size of SNMP datagrams. With NETCONF, you actually can stream bulk data because it's carried over TCP. You don't hit an artificial limit. You're able to just fetch a megabyte of information in one operation from the device because we can stream it over TCP. In fact, measurements and research has shown fetching of bulk data from a device is an area where NETCONF really shines in performance compared to SNMP because we're able to stream over a TCP connection. It really does give, significantly faster transfers of bulk transfer of data. Things like transactions. SNMP doesn't have transactions. You set something. Then you need to do a get of it to see, did that set really take? With NETCONF, we have the idea of transactions. We get positive acknowledgement of the device that all of our changes in that transaction have happened. We're also able with NETCONF to use various operations that it has to control a transaction that spans multiple network devices so that those devices all have their configs changed or they all remain at their starting configuration. There's the idea of being able to invoke administrative actions in a device. Sometimes you need a device to do something that doesn't necessarily involve data. It's not a set of a config data. It's not a read of operational data. It's trigger something like reboot a line card in my device. In SNMP, that sort of support wasn't designed from the ground up into the protocol and identified, but people figured out a way to bolt it on. You've maybe heard of writable operational data in SNMP. They came up with some ways of doing it. However, with NETCONF, we've got those sorts of features designed from the ground up. We were using SNMP. It's been around. There was a lot of lessons learned from those years that went into NETCONF, and this is a lot of why NETCONF ends up better. Both can send event notifications, configuration. SNMP, it's hard to back up the configuration of a device because when you get things, you can't say, just give me your configuration. You're going to get a view of data polluted by operational state data. But with NETCONF, you can fetch just configuration data from a system and not have it polluted by operational data, so you can easily remotely back up and restore configurations. If we look at security, SNMP v3 security is fair, but it was more bolted on. It wasn't designed into the protocol from the ground up. If you talk to security experts, they'll tell you, designed from day one for security, it's more secure than bolting it on later. So NETCONF took that lesson learned, designed it from day one. Testing a configuration. NETCONF, I can send a potential future configuration to a device and ask it to validate that configuration for me and, tell me if I asked it to go live with that config that it thinks it would be valid and would be successful. SNMP there's just no sort of concept there for that. But this last point in this slide is the really important use case, and it's been the holy grail of network operators of service activation. Network operators aren't thinking about, I'm setting, turning on this interface, sending my QoS parameter here and this little thing here. No, they want to think of things at a higher level. They want to think of a service that they're activating on the network. I want to have a service that is a VPN that connects endpoints A and B and has these quality of service parameters. That's my service. Make it happen with the device details. As we'll see as we get further into this training series, we'll see that NETCONF and YANG very much enable the ability to do service activation. A key part of service activation is you're changing the configurations of multiple devices, and you want to be able to do that sort of configuration change in a network-wide fashion. So, what is a transaction? We've talked about device transactions, we've talked about network-wide transactions. Well, in computer science theory, we have 4 properties that define a transaction, commonly abbreviated as ACID. Atomicity, consistency, independence, and durability. A transaction is all or nothing. That's what atomic means. Maybe I have 20 changes in this transaction. They all succeed or they all fail. There's no, some of it happens, some of it doesn't. It's atomic. Consistency. Transactions are all at once. It's a set of changes. Order doesn't matter in a transaction. Whether I put, create A and create B into the transaction or create B and create A in the transaction, it's identical. All paths from my start and my end point for the change set of this transaction, all paths from A to B are equal. So giving you a set of changes, and this is the set. It doesn't matter what order I typed CLI commands to populate my transaction. What matters is the set of changes. The I for the ACID properties, independence. Parallel transaction don't interfere with each other. Transactions are independent from each other. So, in other words, they aren't dependent, they aren't going together. I do a transaction, it's a standalone thing, it's independent from any other transactions. Then durability. I'm making these transactional changes. They need to be durable, i.e. persistent in my device. They have to be stored there. If we consider, a transaction here, where maybe we're adding an interface called ETH5 to our device, and we're also adding a route over that same interface. So we populate the transaction, and it's up to the device then to apply that transaction internally. So whether we populate the transaction of add interface, add route, or populate it as add route, add interface, it's the same transaction. It's the execution of that transaction in the device that matters. We end up having a transaction we can populate in any order. It's up to the device then to worry about the actual sequence of the ordering of applying that transaction. What this means is the centralized management system is freed of having to know about, i.e. have software written to implement any of these ordering constraints inside of all these individual different devices that are in the network. Instead, it's up to the device itself to implement that ordering. On transactions, other places are backup and restore. We can read a configuration from a device, save it to a file, use tools to process it. So since we're getting that configuration from a device via NETCONF, which is XML based, we can get the results as an XML instance document and use standard text processing tools or standard XML processing tool chains to process the results, whether it's for analysis, modification, whatever. We can do it because it's human readable. You can also use NETCONF to restore a configuration to a device. You send the saved configuration. You don't need to worry about sorting it. You don't need to worry about chunking it into sizes that fit into my protocol data units. I can just send that transaction to the device, and the device will, apply it in the proper order. Since I'm being carried over TCP, I don't have to worry about size limits. I'm just worried about data and what the data that I'm sending. So if we look at then how transactions get applied to service activation. Again, service activation is something that involves multiple devices in the network. The operator is going to create some new service in there at the OSS level. It may be an IPTV service, it may be with HD quality, it could be a VPN service, but let's use this IPTV example. At the OSS level, we need to compute the configuration changes to send to the network, but this is, any service activation is going to involve multiple devices in our network. There may be IPTV server edits, maybe it involves settings on 3 routers, 2 firewalls, and also, our billing system so we can bill the customer for using the service. Now, with network-wide transaction support that we can do from NetConf, we just send the configuration changes to all the devices in our network. We don't need to worry about sorting it. Each device will validate its configurations. They'll all succeed or they'll all fail. We'll test the service and everything is fine. If there is an issue, since we're transactional, it's easy to roll that back. When we get to the NetConf tutorial and talk about operations such as confirmed commit, you'll see why this makes it very easy to deploy a config on the network for a service, test that it's working, and if it isn't, very easily roll our network back to our starting point. So, really, network-wide transactions is probably the most important leap forward in network management since the SNMP protocol was invented. It enables us to move from managing individual devices to managing networks. And the network operators, the service providers, this is really what they want to be able to do. They're running a network, they want to manage the network, they want to monetize the network, they want to easily turn on new services in their network to have new offerings to their customers. A lot of the details of network devices, of error recovery and sequencing tasks, are removed from the management systems. It's up to the devices. They're the experts on what needs to happen internally. Don't leak that info or make those details necessary to be known at the management system level. If we look at managing the network, remember, the operating expense of the network is much greater than the capital expense of the equipment. The easier it is to operate the network, the more efficient and profitable the network provider can be. So, looking at current status out there, as I've mentioned, NetConf and YANG are standardized by IETF. We've talked about a lot of these features. What are the standards? What is the current status? NetConf has a wide set of RFCs. The NetConf protocol is standardized by the NetConf working group within IETF. You see a link there for it down at the bottom of this slide. There is the base NetConf protocol defined in RFC 6241. There's transport mappings. NetConf was designed to be independent of its transport, so it could be carried on different transports. You'll find RFCs that do talk about different transport mappings. However, SSH is the required transport, and in the real world, SSH is the protocol people are using for transport of NetConf. You'll find, as I mentioned earlier, NetConf is extensible. You can add new operations to it. Well, on the base protocol, we have some standardized new operations, notifications, partial locking, with defaults, etc., that have been standardized in RFCs. There is a standardized access control model, NetConf access control model, or NACM. And, there is active draft work. These things are evolving. So certainly take a look at the NetConf working group at IETF to see what is happening today in terms of involvement. In terms of YANG, the base RFC for YANG is RFC 6020. That's the base specification of the language. It's a very readable RFC, very easy to understand. Then we have, some certain things. RFC 6087, 6244 are good places to start in your reading of RFCs because they give you architectural overview of how NetConf and YANG is applied for network management. They give you guidelines for writing data models, especially if you're going to write a standard model for submission to IETF to have standardized. There's also some various links here at the bottom of the slide where you can actually go to learn more. The YANG RFCs are done by a NetMod working group. NetMod stands for NetConf Modeling. That working group does the YANG RFCs. There's some other links here, YANG Doctors and YANG Central, you can use for learning resources, etc. One thing I haven't listed in this RFC list is, we first had NetConf, the protocol, then we had YANG, the data modeling language. Now out of IETF, we are starting to have standard YANG models that are coming to RFC. For example, there's the system model, there's the interface model. We'll take a look at some of these in subsequent modules of this series. But this will get you started in learning. Take a look at the NetMod working group. You'll find some of those standard YANG models there. So hopefully this module has helped you get a little oriented to the basics of NETCONF and YANG. In subsequent modules in this training series, we'll be doing a much more in-depth, detailed tutorial of the NetConf protocol and the YANG data modeling language. Thank you.